Hello YouTube. In this video, we'll look at one of the utilities called as fsdbStimulus. So it's again open source and hosted on my GitHub page. You could see, you could find it here. Okay, let's see. Git clone, use the clone command. Let's get on with the example. Okay, so introducing the fsdbStimulus utility. It's basically um, you can use the FSDB as your design stimulus. You don't need a test bench for recreating the stimulus. So I have actually listed down some of the usefulness of this particular utility. I'll touch back on that later as well. Let's get on with the example, right? So let's clone. Should take only a few seconds. Yeah. So you can see the source files right in the root directory. So yeah, things are taken care for you with the make files and everything. So just get into a test, and there's only one test right now. So you have the design, which is the xr.sv, which is actually computing the XOR of two different 8-bit variables, A and B. Okay, so this is the attachment that's used during the first run. So this is a attachment for the DAT. So you have instantiated the DAT with the XR, and then you're just having some assertions in here with your normal attachment, and you're just checking. So in the other case, so here you will be dumping the FSDB. This is the first run. And then in the other case, you will be running it with a DAT, which is actually a dummy DAT, which just have the ports. So we just see that this model has ports only. So we'll create two different simulations. So let's see the make dot in. So first we run the VCS simulation to create the stimulus file. So stimulus again an FSDB file, which we are calling it stim.fsdb. So once the stimulus is created, we use that stimulus, right? That's stim.fsdb, that stimulus, and then we run the same design. The design is not there, but the output will be run accordingly. So that's the whole concept. You're using the FSDB to recreate the stimulus. That's the whole concept. So what you do is, so you're in the test directory. So first let's create the stim.fsdb. So you can just do make stim.fsdb. So if the libraries, so it needs a library file which is not, if it's not created, you go and create it. So it created, and then it created the stim.fsdb also to see so we run with FSDB file stim.fsdb. So if you look in the current directory, you will find that stim.fsdb is created. Now we don't have a node.fsdb here, so that's just so here there will be no output that will be created. So output is not created for good reason. I have turned off any verbose output here, but if you look at the message here, it tells that end of FSDB. That means that it has read the FSDB So this is the FSDB that you read, the stim.fsdb, and then this is the FSDB's hierarchy from which we want to play the same hierarchy onto the signals onto another hierarchy. So in this case, so in the during the run case, second run case, like your hierarchy may be different because you're not no longer having the same test bench, right? So there's an option that you can provide to the FSDB to RTL to provide a different hierarchy, but it would take it and it would drive all the signals from this from from the source hierarchy in the FSDB file to the destination hierarchy, the target hierarchy in the second run. So I have used a body NWave. So a well-logged FSDB is created, so you can actually open it and go through NWave. Well-logged.fsdb. So if you do this, you would open a waveform viewer and you can check it. So yeah, on the uses of this particular utility, I've actually captured it on one of my web pages. Um, so the first important thing is like actually two different users. One is like you have export control test bench, a complicated test bench, and for some reason you are not able to export the failure to the vendor, but probably an IP company, right? So you have a test bench, but you can't export the test bench because the test bench is also like a huge code base and it's export restricted and it can do that, right? So if you have a failure case, for example, a VCS is misbehaving, simulator is misbehaving, you have failure, and then you want to export that failure, right? So you can use this particular utility. The other one is like yeah, I think I combined both of it together and then I gave it as one reason. Basically, the two different reasons are one is you wanted to export, you don't want to export an export restricted source code. That's one reason. And the other one reason is you have a very complicated test bench that you can't export, right? So to replicate the same thing in an IP, or or you have a different hierarchy because like you have got an IP which is from vendor, and then you have created a design out of it, and you have a DUT, and in that DUT it fails. So, but you don't want to, and your stimulus generation is very different than the IP, and then at the IP level is what you want to export it. So you can use this utility to when you export the FSDB, like the user or the vendor actually can replicate the failure with your FSDB. Yeah. So I hope I was able to clear a doubt on this utility. Yeah. So this is again one useful utility that I've been using in my day-to-day work. Uh, Yeah. So I suppose releasing it on open source should help others who have similar problems, similar challenges. Yeah. And then I suppose think people will adapt to it and use it. Thanks a lot. See you too. Bye bye.